Hi students, welcome to the chemistry sessions. So in this particular session we will be discussing set of 10 questions which I have brought for you, and you will be having 1 mark, 2 mark, 3 mark and 5 mark as a pattern set over there. Okay, so you have to be ready, well prepared. I hope everybody has watched all the lectures that we had and are thorough with the concepts. So let us move on to the question number 1 in this case of, so acid, bases and salts is what we are actually discussing over here. Fine. Okay. So the question number 1 says 1 mark question, is it? Okay. And as per the 1 mark, you have to be very precise for your answer, very brief. Fine. What color do you do the following indicators turn when added to a base or alkali? So what, do not get confused over here, it's one and the same thing, base and alkali. So they are adding just the base, just the alkali to all of these indicators, and what will happen, which color change would you observe? Okay. So see here, methyl orange. So the actual color of methyl orange is orange in color. Okay. And whenever we add some base onto it, it gets converted into yellow color. Yes, that is right. For acid it is, whenever we add acid, it turns into red color. So litmus. Okay, so litmus, whenever we try to add alkali, so as I was telling you that litmus paper in the case of alkali, in the case of base, so base stands for B, that means it will get converted into blue color. So red to blue is the conversion, okay. Red color to blue color, it got converted, the litmus. Next one, red cabbage extract. So I was taking red cabbage extract, added a little base. If I add acid, let's say, what will happen? It will remain red only, but at the moment I add base onto it, it will get converted into green color. Yes, so green color we will be obtaining here, and that completes question number 1. So that was a pretty easy question. We have already discussed that in the lecture. Now question number 2. Why do HCl, H2SO4 and HNO3 etc. Okay. Yeah, so actually they have categorized all of these things. What are these things? These are acids, and that too very strong acids. Show acidic character in the aqueous solutions, while solutions of compounds like C6H12O6. Now what is this? Glucose. C2H5OH, what is this? Alcohol. So these two, they do not show any acidic character. So they must have studied their acidic character through maybe some indicator, fine. But they did not get any results in the case of glucose and alcohol. So what is the property of an acid, and what is responsible in the acid to show that acidic character? It is the H positive ions. See here, whenever we try to dissolve it in water, it gives H positive. Here also it gives H positive, etc. So these are only responsible for that color change, for that indication. Whereas if I talk about glucose and alcohol, so they do not give H positive ions in the medium. Okay. So they do not give any H positive ions, and that is why they are not at all acidic in nature. Fine. Okay. So this was question number 2. Just a one-liner you have to write over here. Coming on to the question number 3, which gets to be 2 mark question. Name one natural source of each of the following acids. So you should have the knowledge, the correct knowledge for it. Citric acid, the very easy, it's present in the lemon. Maybe it is present in the oranges, yes. Now oxalic acid, where is it present? Just think about it, where it is. If I talk about the lactic acid, where it is? Yeah, so from lactose you can just correlate, lactose is milk. So it is present in the milk. Or I can just say the curd. When milk gets turned into curd, the only acid which is responsible for it is the lactic acid. Now coming on to the tartaric acid. So the tartaric acid, it's present in the grapes, and that too those sour grapes, the unripe grapes. Okay, so the oxalic acid, where is it? It is found in tomatoes. Okay. Fine. Now let's move on to the next question, question number. So yeah, since this was 2 mark question, each part will be given as half mark if you get it right. Fine. Now question number 4, an interesting one. a milkman adds very small amount of baking soda to the fresh milk, why does he shift the pH of the fresh milk from 6 to slightly alkaline? Earlier it was 6, that means acidic. Why acidic? Because it has got lactic acid into it. Now it turned into slightly alkaline by adding baking soda, which is a base. Why he has done like that? So basically, whenever there is overproduction of the milk, when you keep milk for a longer while, what will happen? The bacteria in that, or maybe the lactose, it starts getting converted into the lactic acid. More the acid, more. You must have seen also that after a while, milk starts getting spoiled, start getting sour, gets turned into curd. Why? Because of the lactic acid. So just in order to prevent that thing to happen, to prevent the conversion of milk from the curd, he has put a little amount of base. What will happen? Now the lactic acid will be produced. Then this lactic acid will not affect the consistency of the milk and will not turn into curd. It will first try to neutralize the baking soda which is present. Okay, the baking soda, which is a base which is present. And that is how we can store this milk for a longer while. And baking soda, although it does not affect our health as well. So that is how the milkman did. Okay. Now, so that was question number 4, pretty interesting one. Now moving on to the question number 5. Now question number 5 to 7, 3-mark questions. You have to be very careful while answering how much to write. You should be knowing that. Now 3-mark question, what is an indicator? An indicator which gives us an idea whether something is a base or a acid. Okay? Or maybe it can also tell us the pH of a salt. If there is a strong salt, that means formed from strong base and strong acid, it will be a neutral pH. Whereas if I talk about those weak salts, maybe having weak bases or having weak acids, so the pH will again vary. It will not be neutral. Okay? So that is what an indicator is. It indicates the nature of the compound, whether it is acidic or basic in nature or neutral. Now, name 3 common indicators. We just did. Methyl orange can be one, litmus can be another, and the third one can be either, let's say, phenolphthalein. Okay, phenolphthalein is also an indicator. Now, name the acid base indicator abstracted from lichen. Now, lichen or lichen, whatever you call it as. So this is responsible for the litmus paper that we use. Okay, so that is the acid base indicator. For acid, the litmus gets converted into from blue to red, and for base, red to blue. Getting it? Now what color does the turmeric paper turn when put in an alkaline solution? So you must have got those turmeric stains on your shirts sometimes, some maybe. So what happens is, whenever we try to wash it with some detergent, which is a base again, okay, washing soda. So what will happen? This alkaline solution will turn into reddish brown color of the turmeric, which is the stain on your shirt is, okay, reddish brown in color. So this turmeric paper got turned into reddish brown. So that is how the natural indicator acts. Okay. Now, so this was question number 5. You have to be very good while explaining each one of the parts in order to fetch all the 3 marks, the entire 3 marks. Now, what is meant by strong bases and weak bases? Now, strong bases, first of all, what are bases? Which give us OH negative. So the strong ones are those which are capable of donating all the OH negative, whatever they have, and very quickly. So these are very strong bases. Weak bases, which are not capable of donating all the OH negative which they have, maybe it is going to be a slow process while dissociation. So those are known as weak bases, which have got a little less basicity. Fine. Now classify the following into strong bases and weak bases. Fine. Okay. So this is going to be, yeah, this is going to be the weak base. Out of these two, these are strong bases if you see. While moving on to calcium and magnesium, what you can say is calcium, it's kind of a strong base, I can say, or it is sometimes included in the category of weak base also. So, I am just calling it as weak. Magnesium, it is going to be strong. Fine, strong or weak. Slightly they are weak, okay, but yeah, we include them in the category of strong or weak as well. Fine. So, these two, even if you answer weak, then it is also correct. Fine. Okay, now moving on to the question number 7. What do we have? Okay, what happens when a concentrated solution of sodium chloride, that is the brine, is electrolyzed? Write the chemical equation. Electrolysis of sodium chloride in the production of what? In the production of Cl2, H2 and NaOH. Yes, and this process is known as chloralkali process. Okay, so yeah, what we have taken is NaCl. I need to electrolyze it in the presence of water. Yes, what do we get is NaOH, that is a base, plus Cl2 plus H2. Now, the question is, why is the electrolysis of concentrated solution of sodium chloride is known as chloralkali? Can you tell me? Because it leads to the production of an alkali and chlorine. Fine. Name 3 products of the chloralkali process. I just told you. Fine. State 2 uses of each one of them. Let's discuss the uses now. NaOH, it is used in soaps. Yes. It is used in detergents, it is used in paper industry as well. Fine. Into various kind of chemical reactions it is used. So, in different kind of industries it can be used. Now, Cl2, most prominent is the disinfectant. Disinfectant. What else? It can be used as a manufacturer of bleaching powder. Okay. So, bleaching powder can be the one. What is the formula for bleaching powder? CaOCl2. So, here you can see very well that there is chlorine involved. Now, hydrogen, it can be used as a rocket fuel. It has got a lot of energy and it is explosive as well. It can be used as in the manufacture of ammonia as well. What is ammonia formula? NH3. So, definitely hydrogen would have been involved in the process. And yeah, that completes question number 7 as well. Fine. All the 3 parts done. Now, so this was question number 7 that I had got. Let's rub this off. Yeah. So, let's move on to question number 8. And this is going to be interesting one. 5-mark question. Okay. So, what effect does the concentration of H positive ions have on the nature of the solution? So, more the H positive ions, more acidic will be the solution. Fine, somewhat related to pH. What effect does the concentration of OH negative ions have on the nature of the solution? More the OH negative ions, good is the base. So, it is a basic solution. Now, someone put some universal indicator paper, yeah, into vinegar. The pH is 3. What does it tell you about the vinegar? Vinegar is acidic and the paper will turn out to be a little orangish red in color. Okay. So, it will tell us about the acidic nature of the vinegar and it will turn out to be orange red colored. Fine. Someone put some universal indicator paper onto the wet soap. Soap is a base. The pH is 8. What does it tell? That soap is basic. Yes. And the color would turn out to be a little greenish. Yes. So, the color would be green. Now, state whether a solution is acidic, alkaline or neutral. So, we need to choose in these 3. Fine. About the pH values. 9. So, what do we know about this pH indication? Yeah, something like this. So, starting from ranging from 1 to 7 and then to 14. This area, it indicates acidic nature, it indicates the basic region and the middle one is neutral. Okay. Now, state whether a solution is acidic, alkaline or neutral. This is alkaline, yes. Now this one 4 acidic, 7 neutral, yes it is neutral, 1 very acidic, so it is very acidic, almost the starting value it is, 10 very basic, fine, and number 3 acidic, moderately acidic, cool. So yeah, that completes my question number 8 as well. I hope everybody has followed up and understood this. Okay, so coming on to the question number 9th, what do I have? Now, consider the following substances. All of these substances have been given, which you see over here. All of them would be familiar to you, yes? Now, what they are asking, which 2 substances combine to form bleaching powder? Now, what is bleaching powder? We just discussed its formula, CaOCl2, yes? From which compounds do we form this? So, first is slaked lime, yes? Let's discuss the reaction also. Slaked lime plus Cl2, we get CaOCl2, fine. So, which 2 substances are there? One is slaked lime, okay. Let me just write it here, plus Cl2, fine. These are the prime components. Cl2 we have it in here in the list. Which 4 substances are utilized in the production of the washing soda? Now we have actually read about this washing soda production via Na2CO3. But from where do we get this Na2CO3? While production of baking powder, yes? So the production of baking powder, it involved 4 components, NaCl, NH3, H2O and CO2. This has led to the formation of NaHCO3, which then got heated to form Na2CO3, and finally again I used up water, yes, this component, to get washing soda, Na2CO3 dot 10H2O. That means 4 components are this and this. These are the unique components, yes. So let us just recognize these. Yes, NaCl I have, NH3 I have. These are the prime components actually. If you say that yeah, this can be a component, this can be a component, no. The initial ones, the starting ones, which has actually led to the production of washing soda, are only 4. One is NaCl, another is ammonia, then water, and then CO2. Cool? Now, moving on to the question number 3. Which compound represents plaster of Paris? Can you tell me out of all of these? So, I have got 2 options right here. One would be gypsum, another would be plaster of Paris. So, plaster of Paris is calcium sulfate hemihydrate, that means semi-hydrate. So, is this hemi? That means half of it? No. But if I just try to divide this entire equation by 2, that means divided by 2, divided by 2. That means this will going to be CaSO4 plus dot how many? Half of H2, yes, and that is what the POP is coming out to be. So it is CaSO4 calcium sulfate hemihydrate, half of H2O. Got it? Now which compound is a part of baking powder? So I just told you, baking powder it is. Not they are asking about baking soda, but baking powder. So baking powder is what? Whenever we have the baking soda, yes, NaHCO3 plus edible oil plus some acid when we add, yes, then only we get the baking powder. Yes, so the major component which is involved is NaHCO3, and that is my answer right here. Okay, so no need to get confused between baking powder and baking soda. Revise it once again. So it is NaHCO3. Got it? Which compound is used as an antacid? Again, baking soda. Yes, baking soda, or yeah, baking powder. So baking powder is actually used in the cooking purpose, whereas this baking soda, NaHCO3 only, it is used for the antacid purpose. and yeah, that is NaHCO3. Cool? Okay. Yeah. So that completes my question number 9 as well. So we are just left with only one question, that is question number 10, and let us have that question finally. Okay, what is a salt? Give the names, yeah, just try to correct it, give the names and formulae of any two salts. Also, name the acids and bases from which these salts may be made. Okay, so what is a salt? Whenever a base tries to combine with an acid involved in a neutralization reaction, giving a neutral product is known as a salt. Yes, so salt is ionic. First of all, it's an ionic compound. Whenever base plus acid it gets combined, we get a salt. Yes, okay. And yeah, one more thing is important, it's neutral. It's neutrality, fine. Okay, give the names and formula of any two salts. Okay, any two salts, let's talk about NaCl and let's talk about KCl, fine. From which these, from which acids and bases these salts have been made. Okay, so see here, Na, it came from NaOH, one base and one acid I need, that means it would have been HCl. KCl, similar way, KOH plus HCl, giving KCl plus, in both of the cases, I obtain neutral water as well, just in order to complete the entire equation, fine. Okay, so yeah, that completes A part. What is meant by a family of salts? Explain with the examples. So do you see any family of salts over here? Yes, I do see. See here, family means having one member in common. Two chlorines are there and that is a family. If I just try to have a family associated with Na, can I do that? Any salt, NaCl can be one, Na2SO4 can be one. So these two are also included in a family. Some of you might be having this confusion that can NaOH be added in this family? No, it is then going to be a base. So bases are not included. These are salts that we are talking about. Also, yeah, Na2CO3 can be one. Fine? Okay. So that is a family that we have. And in a similar way, we can have different families of maybe potassium. So if we talk about family, it can be because of the same positive ion or same negative ion, right? Okay. What is meant by hydrated and anhydrous salts? I have told you ample amount of times about this. So hydrated means having some water molecules associated with it, but still they are solid. Anhydrous means no water molecules associated. Explain with the help of examples. I can. Copper sulfate anhydrous, having no water molecules associated, it will be whitish in color. Whereas if I just try to add a few drops of water onto it, it will start turning blue. Yes, and this blue color is because of the hydrated salt which has now formed. These 5 molecules of water have been stuck onto the crystal, into the crystal of copper sulfate, making a complex compound. It is not a solution at all, but a complex which is formed right here. Okay. Now, this one is done. Write the names, formula and colors of any two hydrated salt. I just told you about the copper sulfate. Yes. One more that I can take is, we just discussed, Na2CO3.10H2. What is this? Washing soda. Yes. What probably can be the color for this compound? So washing soda is, kind of whitish transparent, or I can say just translucent crystals, right? So these are somewhat translucent or maybe whitish crystals, right? Fine. Okay. Now that is the D part which has been done. Last one. What will be the color of the litmus in the aqueous solution of ammonium chloride salt? Going to be very important, okay? So just listen up carefully here. Ammonium chloride, they are actually putting it in water. So what is this reaction known as? Salt hydrolysis. Remember? I'm putting it in water. So basically this is hydrolysis. what will happen? From whatever base or acid this particular salt has come up, we need to write those. NH4 corresponding to NH4OH, which is a weak base, plus HCl corresponding to Cl into this salt. Yes, so this is a strong acid and this is going to be a weak base. That means which will have the majority in here? Either H positive or OH negative, either of the two. So since this is weak base, there will be very less of OH negative ions. Now, this is going to be a strong acid, that means more of H positive into the solution, having the majority of H positive, having an acidic pH of it. Fine. So what will be the color of the litmus? Since the solution is going to be acidic in nature, more of acidic, yes, so it will be turning this litmus from blue to red, okay. So it becomes from blue to red because the solution is going to be acidic in nature. Got it? So that completes my question number 10 as well. I hope everybody has understood the entire set of 10 questions. Still, if you have got any doubts, you can reach out to me. Have a nice day.